So when we're working out the power of the grasshopper, it's a pretty good idea to think about the equation for power. So power is equal to energy divided by time. Now, what energy has the grasshopper got? Well, we can think about the energy it's acquired when it gets to the top of its jump. Okay, so we can work out the potential energy of the grasshopper at the top of the jump. So that means we've got to estimate how high it jumps and the mass of the grasshopper. As we know, g is approximately 10. So we say the mass of the grasshopper is equal to a gram, which is 1 times 10 to the minus 3 kilograms. And we could say the height of a grasshopper jump is approximately 1 meter. So therefore our energy is 1 times 10 to the minus 2 joules. So now we've got the energy, we need to work out the time to work out the power. To do this, we have to think about energy considerations again. So we assume that all the kinetic energy is being converted into potential energy. This will allow us to get a velocity of the grasshopper as it leaves the floor. So we set mgh equal to half mv squared. We do some algebra and we end up with the speed is equal to the square root of 2gh. Subbing our numbers back in again for g is approximately 10 and the height approximately 1, we can say that the velocity is approximately 5 meters per second. Okay, so we have our energy, we have a velocity, but we haven't got our time still. You may ask, why have I calculated velocity? But we can get a time scale from our velocity approximation. So if I say that the velocity is equal to the distance divided by the time, I can rearrange this to say that the time is equal to the distance over the velocity. Now what is that distance? Well, this is the distance where the grasshopper is actually accelerating to get up to some sort of velocity of 5 meters per second. So that distance is the size of the grasshopper's legs. So we could then say maybe a grasshopper's legs, when extended, it's quite a big grasshopper, maybe 5 centimeters. So I could then say that 5 times 10 to the minus 2, which is 5 centimeters in meters, divided by my 5 meters per second, and I'm going to end up with 1 times 10 to the minus 2 seconds. So now I have all I need to calculate the actual power of the grasshopper. I have my energy and my time. So now all I do, it's come out very nicely, is I can say power is equal to energy over time, which is equal to 1 times 10 to the minus 2 divided by 1 times 10 to the minus 2, which is 1 watt. So the power of a grasshopper is about a watt.